All right, folks, it's Bass Action back in action here. You're going to notice this video is a little different format because I need to be able to point to some things as we go through this multiplication process. Multiplying matrices can be challenging for some people, so I want to give you some tips on how to do this process effectively because we're going to do it a lot. Okay. First of all, on the previous video, we talked about an additive identity matrix, meaning it's a matrix that I can add to another matrix without changing the matrix that it's being added to. A multiplicative identity matrix works the same way. It's a matrix that I can multiply times another matrix without changing the original matrix. Now, let's fill in these blanks then, because that's all that's saying, is that the multiplicative identity matrix does not change the original matrix when we multiply. Now the catch is that a multiplicative identity matrix has to be a square matrix, meaning the rows and the columns have to be the same number. So this notation right here, this I sub 4, means it's a multiplicative identity matrix of dimensions 4 with 4 rows and 4 columns. So if we wanted to write the multiplicative identity matrix that has the dimensions of 5, what I would do is I'd start off with a 1 up here in the corner and then 1, 2, 3, 4. Because what we're noticing when we look at that multiplicative identity matrix is that there's these 1s all the way down this column or this diagonal, and then everything else is zeros. So I'm just going to follow that pattern. So now I'm going to have a 0 and a 1 and fill in the rest zeros. And then a 0 and a 0 and a 1 and then zeros. And then a 0 and a 0 and a 0 and a 1 and a 0. And then our last one. And then what we can see is this is going to be what we call our identity matrix, our multiplicative identity matrix. And you'll see this kind of slip in a few places, and we'll start to see why this is a valuable matrix for us to understand. We can put our brackets around this. So there we go. So to multiply matrices, our rules are a little bit more complicated than with adding two matrices together. When we added our two matrices together, all that was necessary was that the dimensions were exactly the same. When we're multiplying, we have a little bit more in terms of requirements. What we need is that we need the number of columns in our first matrix to match the number of rows in the second matrix. Now, this language is a little bit harder, I think, to understand than if we just look at it. If these are the two matrices that we want to multiply, these are the values that need to match. The columns in the first and the rows in the second. If those are the same, then yes, these two matrices can be multiplied together, and then our new matrix will have the dimensions of what's left here, the m by r. Okay, now understanding what the new matrix is going to look like is really, really helpful as we work through our multiplying process. So first of all, let's take a look at these two matrices. What we're going to do is we're going to first check our dimensions, just make sure that we can even multiply. Let me slide this up for a little bit more for you. So first we're just going to make sure we can multiply. The dimensions of A are 3 by 2, and the dimensions of B are 2 by 2. So these certainly couldn't be added together. However, since these are the same, then we can multiply, which means our new matrix, and this is good to recognize from the beginning, our new matrix is going to have 3 rows and 2 columns. It is just a coincidence in this case that these dimensions are the same as the first. That does not always happen. We're going to see this a lot. Okay, so in terms of multiplying, so now we've got these two matrices we want to multiply. We've verified that we can. This is our formula, so to speak, but this looks pretty complicated. So what it's telling us is that we need to take this row times this column, and then this row times this column, and this row times this column. And that might still seem like gibberish to you, so let's just look and see how this is going to work. What can be helpful for a lot of you is if you do a little covering up so that we can just see the parts that we want to use for this first process. My goal is to multiply this row in this column, and that's going to give me the first element in my new matrix. So when I do that, what I'm going to have is I'm going to have a 1 times a 2. So I'm going to have this 1 times a 2, and I'm going to add that to a 3 times a 6. Now, as we progress, we're not going to always write all this down. So this together will give me, this is going to give me the first element that will go right here. Now my next one, now I want to take the next row and multiply it by that column. So now I'm going to do 4 times 2, and I'm going to add that to a negative 2 times a 6, and then I'm going to do 0 times 2, and I'm going to add that to a negative 1 times a 6. Now what might help you understand what we're doing here is that this then gives me a 2 plus an 18. This gives me an 8 plus a negative 12. And this gives me a 0 plus a negative 6. So that's going to simplify. But let's keep going. This then will become this whole first column. Now, that takes care of this first column. And now we're going to move on to our second column, and we're going to repeat that process. There's my sticky note here. And again, just because it's sometimes helpful to hide the numbers we don't need. So now we're going to do 1 times 5. And I'm going to add that to 3 times negative 3. Then I'm going to do a negative 4 times 5. Or a positive 4, I meant to say, times 5, and a negative 2 times a negative 3. Then I'm going to have my 0 times my 5, and my negative 1 times my negative 3. Each time noticing that I'm just covering up the parts that I don't need. Rows times columns, rows times columns. So now I'm going to clean this up. This gives me a 5 plus a negative 9. This gives me a 20 plus a 6. This gives me a 0 plus a 3. And then we're almost done. So that my final answer, 2 plus 18 is 20. 18 and my negative 12 is negative 4. 0 and my negative 6 is negative 6. 5 and a negative 9 is a negative 4. 20 and 6 is 26. And 0 and 3 is 3. So this is our final answer, and sure enough, it has the dimensions of 3 by 2. Okay, let's look at another example. Let's do another one, just so that you can see 2. So again, first we're going to check our dimensions. Our first one is a 2 by 2. Our second matrix is a 2 by 3. These match, which means our new matrix is going to be a 2 by 3. Okay, so now, again, I'm going to do the covering up because I think that that is really helpful for people to see. So I'm going to cover this one up. And I'm going to cover this one up so that I can just see the first row and the first column. And this is where I'm going to start to get a little bit more efficient with it. I'm not going to write out all the stuff I did in the beginning. I know that 1 times 6 is 6, and I'm going to add that to a 30. Then right below that, I'm going to get a 30 for the 5 times 6, and I'm going to add that to a 3. Okay. That takes care of that one. I'm going to move on to my next column and go back to the first row. So now I'm on the second column. 1 times 7 is 7, and I'm going to add that to the 20 for the 10 times 2. Then I'm going to have 35, and I'm going to add that to a 2. Then I'm on my last column now. I can move my sticky note out of the way. Eventually you don't need the sticky notes, but I thought it would be helpful for you to just see things covered up. Might make it a little less busy for you here. So then on my next one, I'm going to have a 4 and a 50. And I'm going to have a 20. And I'm going to have a 5. So then I just clean all of that up, and I get my final answer of 36, 33, 27, 37, 54, and 25. And that's our final answer. And sure enough, those are the dimensions that we were expecting, a 2 by 3. Okay, so maybe practice that. Maybe try reworking these notes before you come to class. See if you can get this process down, and then we're going to do a whole bunch more multiplication in class.